we have to find the sixth term of harmonic progression. First term of harmonic progression is 4 over 15, 4 over 11 is the second term, and 4 over 7 is the term or harmonic progression. So first let me remind you that the sequence is called a harmonic progression if the reciprocals of its terms form arithmetic progression. So when we take the reciprocal of these three terms, we will have arithmetic progression. So let me take the reciprocal. So it will be 15 over 4, the first term. The second will be 11 over 4. The third will be 7 over 4, and so on. This is arithmetic progression. Let's check. We know that in the arithmetic progression, the difference between the two consecutive terms is constant, d. So if this is a1, a2, a3, so the difference between a2 minus a1 will be equal to a3 minus a2. So a2 is 11 over 4. a1 is 15 over 4. And let's check what we have when we subtract a3 minus a2. Will be 7 over 4 minus 11 over 4. Subtraction of fractions, the same denominators. So we copy the numerator and we subtract numerators. 11 minus 15 is negative 4. And what we have on the right side, the numerator we copy, 7 minus 11 is negative 4. So we see that the canon difference, d, what is negative 4 divided by 4 is negative 1. So we have d, the canon difference. We have first term of our arithmetic progression is 15 over 4. And what we have to find? We have to find the sixth term of harmonic progression. Like I said, we know that the sequence is called harmonic progression if the reciprocals of its terms form arithmetic progression. We calculate that when we take the reciprocal of these three terms, we have arithmetic progression with the first term a1 15 over 4, and the difference d equals, canon difference d equals negative 1. So when we have to find the sixth term of harmonic progression, what we need to find? We have to find the sixth term of arithmetic progression. And when we have sixth term of arithmetic progression, we will take reciprocal of this term and we will have harmonic progression. Sixth term of harmonic progression. So how to find the sixth term of arithmetic progression? We will use formula for the nth term of arithmetic progression. When we have arithmetic progression, the nth term is an is first term plus n minus 1 times d, canon difference. In this example, we have that n is equal 6. So what we have? a1 plus 6 minus 1, we substitute n by 6, times d. What else? a1 we have given, d we have given, we calculate. So what a6 will be equal? a1 we substitute by 15 over 4 plus 6 minus 1 is 5 times d is negative 1. So this is equal 15 over 4. 5 times negative 1 is negative 5. So this is equal, what we can do? Because we have fraction here, I will change this constant number 5 to fraction with denominator 4. How I will do this? I can always write that 5 is 5 over 1. So let me copy first fraction, we have 15 over 4 minus 5 over 1. It's still 5. I didn't change anything. And now, because we have subtraction on fraction, we need to have the same denominator. We have 4 and 1, so we need to multiply 1 by 4. Whatever I did with denominator, I have to do the same with numerator. So we have 15 over 4 minus 5 times 4 is 20. 1 minus 4 is 4. And now when we have the same denominators, we copy denominator and we subtract numerators. 15 minus 20. So we can write that A6, the sixth term of arithmetic progression is, the denominator is 4, 15 minus 20 is minus 5. We copy the sign of larger numbers, so negative 20 we have here, and we subtract 20 minus 15 is 5. So we found the sixth term of arithmetic progression, and because we need to find sixth term of harmonic progression, what we have to do only? We have to take reciprocal of sixth term of arithmetic progression. So what it will be? It will be 4 over negative 5. And this is the sixth term of harmonic progression. This is my solution.